Okay, I assume you've read and worked the problem, so let's jump in here. I think it's a pretty easy one because it just uses a lot of your definitions. So if you know your definitions from your Cintiq card, this should be a very high scoring question. Okay, so part A is the horizontal movement going to the right or left at t equals 2. Well, in order to do that, you need the derivative. If the derivative is positive, you're moving right. Derivative is negative, you're moving left. And we already have the derivative. So part A, we're going to take dx dt. We're going to evaluate when t is 2. Plug it in, we end up getting a positive number. I don't even really care what the number is. So the particle is moving right. And that part was 1 point. Now it also says find the slope at time t equals 2. Now remember the slope is dy dt over dx dt. So when dy dt divided by dx dt, we're evaluating at t equals 2. We get approximately 3.055. That, believe it or not, is worth 2 points. One for knowing this relationship and one for the actual answer. Okay, part B, find the x-coordinate. Okay, let me go to the next page here. Find the x-coordinate of the position at t equals 4. Okay, so we're given this right here at t equals 2. We're asked for t equals 4. So I'm going to do the integral from 2 to 4, right? I have to use what I'm given, what I'm asked. And we're finding, let's see, the x-coordinate. So I'm going to use the x derivative. Now remember, that will give me the position at 4 minus the position at 2 by the FTC. But at time 2, I know its x position is actually 1. So I have the integral of 2 to 4 square root of t plus 2 e to the t dt. It's x over 4 minus 1. So add 1, use your calculator. We end up getting 1.253. That part was worth 2 points. One for this integral and one for the answer. Okay, part C, this is just definitions here. Find the speed. Well, the speed, part C, is the square root of the x derivative plus the y derivative squared, both of them squared. But we are at t equals 4. Okay, we are at t equals 4. So I'm going to plug in 4. I'll get the square root of 6 over e to the 4th. Now remember, it's the derivative squared. Plus, plug in 4. I get sine squared of 4 squared. It approximately 0.575. Also ask for the acceleration vector. Okay, so that's one more derivative. So my acceleration vector, I'm going to use my derivative at a point for that one. I'm not going to waste my time finding it by hand. So I'm going to go ahead and use my derivative at a point, and you're evaluating at 4. So you have negative 0.041, 0.989 when I do my x and y derivatives at a point. Part C was worth 2 points, one for the speed, one for the acceleration. Part D, distance traveled. Well, that's another Cintiq card. So we're going from t equals 2 to 4. Now we're in both variables. So remember, it's the dy dt squared plus dx dt squared. So in our case, they already have the derivatives there. dt, we get approximately 0.651. And that was worth 2 points as well. So very straightforward question if you know your Cintiq cards.